combinatorial term. We want to show something related to this term. We want to show that for any non-negative integer n, the summation of 2n plus 1 choose 2k multiplied with minus 1 to the power k. We sum this up for all the possible values of k ranging from 0 to n, so we will get the integer value here. We want to show that the sum will not be divisible by 5 for any case of n. Okay, so let us take a look of what it means. Okay, before we do so, briefly, let's take a look of what it is about. So when n is equal to 0, what does that mean? So when n is equal to 0, 2n plus 1 is equal to 1. And then we are going to add terms of 1 choose 0 multiplied with minus 1 to the power 0. And that's all. When n is equal to 1, 2n plus 1 is equal to 3. And we will be looking at the terms 3 choose 0, 3 choose 2. But then one of them is plus and the other is minus. When n is equal to 2, we will be looking at the terms 5 choose 0, 5 choose 2, 5 choose 4, and then we will oscillate between positive and negative. In particular, when n is equal to 0, we will just have one term, 1 choose 0, and it is equal to 1. When n is equal to 1, there are going to be two terms, 3 choose 0 and 3 choose 2, oscillating between plus and minus. And after doing the summation, we will get it is minus 2. N is equal to 2, we will have 5 choose 0, 5 choose 2, and 5 choose 4. And then it is equal to, if my calculation is correct, then it is going to be minus 4 in the summation. And when n is equal to 3, we will have 7 choose 0, 7 choose 2, 7 choose 4, 7 choose 6. And then oscillating between plus and minus, we will get 1 minus 21 plus 35 minus 7. And it is going to be equal to 8. Okay. So none of these numbers, so none of them is divisible by 5. Now, for the term that we want to compute, it seems to be related to this expression. This is the binomial expansion of 1 plus x to the power 2n plus 1. So this one, after expansion, it is the summation of k is equal to 0 up to n, 2n plus 1 choose, this is going, not n, this is going to be 2n plus 1. So this one should be 2n plus 1, okay. 2n plus 1 choose k, multiplied with x to the power k. But then this summation, you can separate them into two parts. One part looks at the even powers of x, and the other looks at the odd powers of x. So even powers is 2n plus 1 choose 2k, multiplied with x to the power 2k. And then because we want to have even terms, so we have already 2k here, so the k will now ranges from 0 to n. So here, this should be 2n plus 1, but here it is 0 to n. Another case is 2n plus 1 choose 2k plus 1. Then, in this case, we will be multiplying with x to the power 2k plus 1. Again, the value of k will range from 0 to n. So we have this term and this term. Okay, so how do we get this term? It looks like this term is going to be related to this one, right? So if you look at this, this is minus 1 to the power k. And here it is x to the power 2k. So naturally, we want to set x to be the square root of minus 1. This is the imaginary number I. So by setting x to be I, then we will get 1 plus I to the power 2n plus 1 is equal to, so we copy the same formula in the previous page, except that this is x to the power 2k. We change it to minus 1 to the power k. Is that okay? And for this one, this is x to the power 2k plus 1. So we take away 1 outside, so it is I, and then x to the power 2k, which is minus 1 to the power k. So we will have something like this. Now notice that this is the term that we want to find in our problem. And we want to show that this is not divisible by 5. And this is the other term. And for the other term, it is some integer. This part is an integer, right? Everything is integer, integer, multiplying together integer, summing up integer. So this is going to be an integer multiplied with some I. So in summary, 1 plus I to the power 2n plus 1, we can write it as some integer a plus some integer b multiplied with I. And a here is our target term, and both a and b, they are integers. Okay. Now, when we can do something like this, we can also do something like, let's set x to be minus I. So after setting x to be minus I, we will get this result. So we will get 1 minus I to the power 2n plus 1. It is equal to a minus bi. The same a as before and the same b as before. So in summary, we have, sorry, this is a wrong statement. This is 1 plus, sorry. So in summary, we will have 1 plus I, this is a plus, sorry for the mistake here. 1 plus I to the power 2n plus 1 is equal to a plus bi, and 1 minus I to the power 2n plus 1 is equal to a minus bi. And then we multiply the left-hand side together. Remember, this is 1 plus I, okay? 1 plus I multiplied with 1 minus I, we will get 2. So if we multiply the left-hand side, we will get 2 to the power 2n plus 1. If we multiply the right-hand side, we will get a squared plus b squared. Okay, so far so good, right? Remember, a is our target term. B is some integer. Now, suppose to the contrary that we want to show that a is not divisible by 5. So suppose to the contrary, so we are supposing the opposite. We suppose that a is now divisible by 5. Now, if a is divisible by 5, then a squared is also divisible by 5. So in that sense, when the left-hand side and the right-hand side are dividing by 5, they must have the same remainder. So this one, 2 to the power 2n plus 1, when it is divided by 5, it will have the same remainder as if we are dividing b squared by 5. Okay, so we are claiming that this term and this term, after division by 5, will have the same remainder. Let us take a closer look of the possible remainder for 2 to the power 2n plus 1. Now, when n is equal to 0, it is just 2. And after that, it is 8. 8 is going to be 3. If it is divided by 5, the remainder is 3. And after that, we multiply 8 by 4 again. So when n is equal to 2, it's going to be 2 to the power 5, which is equal to 32. We'll get back to 2. And when n increases, you get 3. So the possible remainder for this number is either 2 or 3. 2, 3, 2, 3, and so on. On the other hand, what we know about b is some integer. So the square of b could be a multiple of 5 squared, so it could be 0. A multiple of 5 plus 1 squared, so it will be 1. When it is divided by 5, the remainder will be 1. A multiple of 5 plus 2, and then we take the square of it, so the remainder will be 4. A multiple of 5 plus 3, we take the square, then again it will also be 4. And then a multiple of 5 plus 4, if we take the square, then this will become 1. So the possible remainder for b squared when it is divided by 5 could only be 0, 1, 4. We see that these two, they do not have any overlapping. So what does that mean? So it means that these two numbers cannot have the same remainder. And a contradiction occurs because we are saying that they have the same remainder here, but we have concluded that they cannot have the same remainder. So we get a contradiction. So in that case, we really show that this is a wrong assumption. So a is not divisible by 5. Okay, notice that if we are talking about division by 5, then minus 1 and 4, they are the same because they have the same remainder when it is divided by 5. So the original term, although we are writing it as minus 1 to the power k, we can actually really replace it by the integer 4 instead here. And immediately we can show that this term is not divisible by 5. And if you are really, observant, then actually you must have observed some pattern here. So we will have 1 minus 2, minus 4 here, right? And then the next term is 8. And actually, the next term will be 16. And the next term will be minus 32, minus 64, and then plus 128, and then plus 256. So if you have a chance yet, take a look, write the program, and let's see if you can make the reasoning about this. But at least we know that it must be related to this term, 2 to the power 2n plus 1. And finally, as a real challenge for you, so why am I preparing this slide? It is because I have come across this challenging problem. This was the original problem that I want to investigate and then show it to you, but perhaps it is better for me to show you the basic idea. So there was a problem in 1974 International Mathematical Olympiad. So this is IMO problem 3 of 1974. And in the contest, we want to show something that is similar to what we have discussed. So instead of 2k, we have 2k plus 1 here. Instead of minus 1 or 4, it is now 8. But the same here, same idea here is we want to show that this is not divisible by 5. We can solve this problem based on a similar idea as before, but it is a little bit more trickier. It is no longer 1 plus I multiplied with 1 minus I. We need to devise some other terms for that one. Okay, so that's all for today. So the basic idea here is that this is somehow related to generating function. So, but then we are not using x as an indicator. We are using I as an indicator. So sometimes it is quite useful to use the I, and perhaps sometimes it is also useful to use something like cosine theta or sine theta as our indicator. Okay, so that's all for what I want to